Hello and welcome you all to this video. Myself, Dr. Nimai Sarkar, currently working as Assistant Professor, Department of Mathematics, VIT AP University. In this particular lecture, we are going to cover one of the most familiar topic of statistics, that is random variable. Okay, so what is basic concept regarding random variable? Okay, through example, we'll try to get the flavor some example, real life example. Fine, then we'll try to cover the thing of different random variable. Okay, one, it is discrete random variable, another is continuous random variable. We'll try to solve few questions as well. Okay, so these are the three topics which we are going to cover in this lecture. Now see, first you have this bookish language, this random variable. This is nothing but one rule x, which will map each of the sample point to some real number. That means x, it is a mapping from sample space to the real number set. Here you can see this is your sample space and this is real line. All right, so here you have omega, it is a point from the sample space. So under this rule you have x of omega is equals to small x, where this small x, it is nothing but a real number. Okay, so this is your random variable. It is a clear cut bookish statement. All right, now we'll try to understand this thing of random variable through one classical example. For example, if you just consider this, suppose this example, if you just consider, suppose you are you are having this random experiment of two coins are tossed simultaneously. You have two coins are tossed simultaneously. This is the random experiment you have. Suppose this one. So in that case, what are the possible outcome? You will get head tail head, and telltale. These are the possible outcomes you have. So this is nothing but your sample space. This is your sample space. Now, just now we have defined what is random variable. Random variable, it is nothing but a suppose a rule which will map each of these sample point to some real number. All right. Now, if we consider x, consider x is a random variable which will represent getting head. So in that case, how many what are the possible scenario you may get? So you may get no head, you may get one head, you may get two head. These are the possible, these are the possible values for x. Okay, so x can either take 0 or x can either take or 1 or 2. These are the possible values that x can take. Now see, what are the sample space point we have? A head tail. So if we just consider x of omega, so that case this x of omega, here we have two head. So you can assign 2 to this particular outcome. You can assign 1 to this particular outcome, because here head it is appearing only once. Here also head appearing only once. You can assign 1. Here no head, so you can assign 0. So you can see here this x omega, it is nothing but a random variable. All right. So this is how we can understand the concept of random variable through example. Okay, so this random variable, it can take the value 0, 1, 2. Okay, so this is one example. Likewise, you may get, see, here another example. This is also a classical example. You are rolling a die. Okay, this is the random experiment you have. So in that case, sample space, it is 1, 2, 3 up to 6. This is the sample space you have. Now, let x denote the face of the die appears on the top. Then you assign this sample space point like this rule. Okay, then this x is random variable which will take the value from 1 to 6. Okay, so these values are also called the realization of random variable x. So likewise, you can construct plenty of random variables and easily you can relate the idea of our previously mentioned definition. Okay. So likewise here few exercises are for you, can try it. Now see, when we are considering this random variable, the story for random variable, so immediately you should you should have two notions. For example, one is discrete notion, another is continuous notion. Okay, so discrete, when you are considering discrete case, for example, discrete means just now whatever example we considered, for example this one or previous one, they are nothing but discrete scenario. Here the observations are finite in number. Okay, finite observation, so in that case you have discrete scenario. If the observations are not finite, so in that case you have continuous random variable. For example, here again you can see tossing a coin. So in that case, head or tail, these are the only possible outcome. So it is a discrete scenario. But whereas if you just think about this example, suppose if you are considering this one, suppose x is defined as height of student in a school ranging between this 120 to 180 semi. Okay, then random variable, suppose you are defining this random variable x like this way, x such that x lies between 120 to 180. Now you may guess here this is a finite case, but it is not a finite, because in between 120 to 180 there are infinitely many points. 120.1, 120.001, so many points are there, so this is not a finite case. And this is example of continuous random variable. Likewise, this is also continuous random variable. Maximum life of electric bulb is 1500 hour. Lifetime of electric bulb is the continuous random variable, and it is written like this way. So you can see 0 to 1500, 0 to 1500, there are infinitely many points. Okay, so you can consider this one as continuous random variable. So these are few basic understanding along with the example. What is random variable? Two type of random variable, discrete and continuous. Now formally we'll see the definition as well. Now see, what is, these are like probability mass function, probability density function. Okay, probability mass function and probability density function. When we consider probability mass function, see, probability mass function, this is nothing but a discrete case. Okay, and probability density function, when you are saying, it is but continuous case. Now see, a set of ordered pair, this x comma fx is a probability function, probability mass function, or probability distribution of the discrete random variable capital X if for each possible outcome, see, small x, for each possible outcome small x, if we have these three conditions, fx greater than or equals to 0, that means all the fx values are greater or equals to 0, non-negative. Next, summation of fx is equals to 1, or sometimes you will get f of small xi, where I varying from 1 to n is equals to 1, the same statement. And third one is p of capital X equals to small x is equals to f of x. Okay, so first one non-negativity, second one this, and third one this. If these three conditions are satisfied, then this fx, it is said to be probability mass function, and this one x comma fx together, they are known as probability distribution. This is probability distribution. All right, and you should clearly note this one, that this comes under discrete distribution. Now cumulative distribution function, we denote it by capital Fx, capital fx, cumulative distribution function of discrete random variable capital X with probability distribution fx. Okay, this is given by capital Fx is equals to probability of x less or equals to small x, less or equals to small x, which is nothing but summation ft, where t less or equals to small x. We'll see through some example as well. This is cumulative distribution function. You may get question like that, find or check whether the given, suppose a function will be given to you, whether this is a probability distribution function or not, probability mass function or not. Okay, find out the cumulative distribution function. One probability distribution will be given to you, question is find cumulative distribution function. Okay, likewise you may get problems. Now suppose we had one problem earlier. In that question, suppose if we are considering, suppose this question, okay, suppose this is your question. Now here we understood that this is a random variable, discrete random variable, example of discrete random variable. Now the question is find find probability distribution. Okay, find probability distribution in this case. So what is random variable? Getting head. All right, now see what we have. X values are 0, 1, 2. Okay, and fx value, you can write this fx value uh, 0 here for corresponding to x equals to 0 means getting no head, getting no head means what will be the probability here? Getting no head. So you can see only one favorable outcome. So 1 divided by total samples, number of point in the sample space 4, so 1 by 4. Okay, here 1. So probability of getting one head. So what you have here, it is one possible outcome, here another possible outcome. So 2 divided by 4. Here 2, x equals to 2 means getting exactly 2 head. So here you have only one outcome, so it is 1 by 4. Now see what you have. Fx equals to 1 by 4 corresponding to 0, 2 by 4 corresponding to 1, 1 by 4 corresponding to 2. So you can easily relate this one with our previous understanding, that if you simply consider this one as x1, this one as x2, this one as x3, then this is nothing but f of x1, this is nothing but f of x2, this is nothing but f of x3. Okay, and what you have, just observe all of this f of xi, they are nothing but greater than 0, all are greater than 0. If you just add them, 1 by 4, 1 by 4 plus 2 by 4 plus 1 by 4, this gives you 1. So that means summation f of xi, it is 1. Moreover, what you have, see this f of this is the first point, this is second point, and here we have the third point, that is probability x equals to 0. What you have? F of 0. See, probability of x equals to 0, it is nothing but f of 0, this one. So this is nothing but probability, corresponding probability of x equals to, see, 1, this is nothing but this one, 2 by 4, which is nothing but f of 1. Probability of x equals to 2, that is f of 2, which is 1 by 4. So these are the 3 points we had from the definition, and you can see it is easily validated here. Okay, likewise you will have example, and from those example you can easily construct the distribution function. Okay, so you try with few problems and this fx, it is nothing but mass function in this case. Likewise here, you can consider throwing a die. So in that case, possible outcomes are 1 to 6. All possible outcomes are equally likely. So in that case, probability of occurrence of each of those outcomes are nothing but 1 by 6. So in that case, one can easily get this distribution table. So you can take this problem. This is another famous question. See, total you have 7 television set containing 2 defective sets. Okay. Now a hotel makes a random purchase of 3 sets. If X is the number of defective set purchased by the hotel, find the probability distribution of X. Express the result graphically as the probability histogram. Okay. So here you have, see, total 7 television set you have. Out of those 7, you have 5 plus 2, means 5 are non-defective, 2 are defective. Okay, a hotel makes a random purchase of 3 set, 3 set, 3 set. Okay, if if X is number of defective set purchased by the hotel, find the probability distribution of X. Find the probability distribution of X. So X, what are the possible values for X? X is the random variable, and there may be the case that not a single one is defective. That means 0. X can take 0 value. There may be the case that one will be defective, one set will be defective, or two set will be defective. Most at most you have two defective. Okay, so at most there may be two defective. Okay, so X can take these three values. All right, now corresponding to that, we just need to find the probability. That means probability of X equals to 0 you need to find. That means probability of getting no defective set. Then probability of X equals to 1, one defective set you need to find. And lastly, you need to find probability of X equals to 2. All these things we need to find individually. Okay, just here have a look. You have 0, 1, 2. These are the possible values X. That means X can take the value 0, 1, 2. Now see, X equals to 0. That means, see, no defective, no defective. No defective means what? How to find the probability? See, here you are taking 3 set from 7, from 7. So how many ways you can take 3 set from 7? 73 ways. Okay, this is the point in the sample space, and those 3 point those 3 set, they will be non-defective. And how many non-defective set you have? See, you have total 5 non-defective set and 2 defective. So those 3 will be coming from non-defective set. So 5C3 divided by 7C3. So if you just do this calculation, you will get 2 by 7. Similarly, one defective. One defective means what? The hotel ordered 3 set. 3 set means 2 set will be non-defective, and one will be defective. Okay, just like our previous treatment, the sample point remain them because 3 you are choosing from 7 set, but here you have, what is the scenario? See, 2 non-defective, so total non-defective we have 5. So 5 to 5C2 way you can take, and 1 defective from 2 defective. How many ways you can take? 2C1 ways. So likewise, you just have this, and finally do the calculation, you get 4 by 7. And likewise, when we consider X equals to 2, that means 2 defective. 2 defective, it is coming from 2 defective sets. So 2C2 way, and 1 non-defective will come from 5 non-defective. So 5C1 way, And just like our previous treatment, we have the same sample point. So do the calculation, you get 1 by 7. So finally, if you just write this one in terms of distribution, so say x values are 0, 1, 2, corresponding probability here you can write, and this is nothing but your probability distribution function. Okay, very simple. Just find the corresponding probability accurately and then construct the table. Cumulative, it is, say here one table it is given to you, x and corresponding probability given to you. Find the cumulative distribution function, so that is capital Fx you need to find. So this is the formula. So what is the process? Just follow it. See, f of 0, 1, 2, 3 up to 4 you need to find capital. Okay, so f0, put the value. Then f of 1 means summation this when t less or equals to 1. It means f of 0 plus f of 1. Put the value, get this one. Likewise, you just go on adding and you will get this cumulative distribution function. So put this x and corresponding capital Fx, you just put, and this is nothing but cumulative distribution. Okay, so likewise here you have few question. You can take a screenshot of this question. First you try, then if you are not getting, then just verify with this solution. Okay, so just like this understanding probability density function, maybe in the next class we'll try to cover up this basic understanding, and also we'll try to solve few question from this probability density function. Okay.